So in this session, we're going to look at combustion of fuels. Combustion is a chemical process in which a substance reacts with oxygen and gives off heat. Now, the substances that we're actually looking at are fuels, and particularly we're looking at hydrocarbons. So let's have a look at an example. So we've got an equation here, and it says fuel, meaning our hydrocarbon, plus oxygen makes carbon dioxide and water. Now this equation is very similar to your respiration equation that you would have learned in biology. So in biology, the respiration equation that you would have learned was sugar or glucose plus oxygen gives carbon dioxide and water. And in both of these equations, what is produced is heat, also heat energy or thermal energy. Okay, so let's actually look at that example. So we've got methane, okay, which is our first alkane, plus oxygen gives carbon dioxide and water. So all we've done is replace the first alkane for fuel in that equation, so methane. So methane plus oxygen gives carbon dioxide plus water. Or we have propane plus oxygen giving carbon dioxide and water. So as you can see, the products are always carbon dioxide and water. When a fuel burns, it reacts with the oxygen in the air, gives off heat, but also it gives off carbon dioxide and water. And we need to remember that, guys, okay? Okay, so let's have a look at this equation. It says methane plus oxygen gives carbon dioxide and water. So that is our word equation. And a mistake that I see in school a lot is people will write methane, a word, plus oxygen, a word, and then they'll put a symbol here, okay? If you've got a word plus a word, these parts have to be words, okay? That's why it's called a word equation, because all of the substances are written in words. Then so we never mix that symbol equation and our word equation up, and it's a common mistake, so please remember that. And I always teach a word plus a word is going to make words, a symbol plus symbol is going to make, it has to be symbols, okay? So that's our word equation, they're written for you, and underneath now I'm going to do the symbol equation. So we have methane. Now meth, it means one carbon. So we've got C, and if it's got one carbon, and our general formula for an alkane is CnH2n plus 2. So if C is 1, that means we've got C1, okay, then we've got H2 times 1 is 2, plus 2 is 4. So methane is H4. And then we have plus oxygen. Now, oxygen is one of those diatomic molecules, and it always travels in pairs unless bonded to something else. Then we have carbon dioxide, CO2. These are common symbols, and water, H2O. So as you can see here, my hydrogens on my reactant side, okay, there are 4 of them. But let's go over here and let's have a look at my product side here. I've only got 2 hydrogens. So you can see that my equation is not balanced. Okay, so I need to make sure it's balanced because atoms just don't disappear. Okay, so we need to try and make sure there is exactly the same number of atoms either side of the equation. So what I'm going to do is I'm going to split my equation in 2. Okay, and I'm going to list on my reactant side what atoms I have. So I've got 1 carbon, I've got 4 hydrogen, and I've got 2 oxygen. Okay, it doesn't matter what order on your product side these atoms are in. Make sure when you're listing them, you list in the same order. That way you won't get muddled up so easily. So we've got carbon, hydrogen, oxygen. And let's put the number of each now. So we've got 1 carbon, 2 hydrogen, and we have 3 oxygen. Now this is a mistake that people make a lot, is they'll say, oh, we've got 2 oxygen, and they forget this one here, okay? So when you're actually counting the number of atoms, you need to count the whole number in the product side, okay? So all of these atoms on the product side. So we have 2 here, 2 oxygen here, and 1 there. So there's 3 in total, okay? So what I'm going to do first of all is I am going to balance my hydrogen atoms, okay? So what I'm going to put is a number 2 in front there. Now that means this whole water molecule is times by 2, because it actually means there are 2 water molecules. So we now have 4 hydrogen, okay, and we have 4 oxygen now, because we have 2 here, and we also have 2 oxygen here now, okay, because remember we had 1 before, and this whole water molecule is times by 2, so we've got 2. So my hydrogen are balanced so far. Happy with that, okay? Now as you can see, my carbon are balanced, so I'm happy there too. But I have, on my reactant side, I have 2 oxygen atoms, but on my product side, I have 4 oxygen atoms. So what I'm going to do is pop a 2 in front of that, and again, that means this whole molecule now is times by 2. We have 2 oxygen molecules, and each oxygen molecule is made of 2 oxygens. So that means now we have 4. And now there are exactly the same number of atoms either side of the equation. And so there now we would say it's a balanced equation. So let's look at another example. This time I have propane plus oxygen that gives carbon dioxide and water. Remember, whenever we're burning a hydrocarbon, and so it's reacting with oxygen, it's always going to make carbon dioxide and water as the product, and it's also going to give us heat energy. Now the general formula for alkanes is CnH2n plus 2, and prop means 3 carbons, okay, so there's 3 carbons. So let's work out what our formula for propane is going to be. So it's going to be C3, and we're going to replace this N with 3. So it's C3H. 2 times 3 is 6, plus 2 is 8. So H, 8. Okay, so let's pop that our symbol equation here. Plus oxygen, remember it's diatomic, so it's always in pairs. And then carbon dioxide, CO2 plus water, H2O. And straight away, hopefully you'd spot it straight away, the number of carbons on our reactant side is different to the number of carbons on our product side. So this is unbalanced, and we need to make sure there are the same number of atoms either side of the equation. So on our reactant side, we have 3 carbon, we have 8 hydrogen, and we have 2 oxygen. Okay, just make sure that the atoms, when we're listing them, are in the same order either side of the equation. Okay, not up here in the actual symbol equation, but in this list here, just make sure they're in the same order. So this time we have 1 carbon, 2 hydrogen, 3 oxygen. Remember, 2 there, 1 over here. So let's look at balancing them. I want to make my carbons exactly the same number either side. So I have 1 carbon here, but I need that to be 3. So I'm going to pop a 3 in front of that, meaning this whole thing now, this whole molecule is times by 3. So now I have 3 carbon. I have 6 oxygen because I have 2 times 3 is 6, plus this one over here, so I have 7 in total. Okay, but my carbon is balanced. So let's look at hydrogen. I've got 8 on my reactant side, I've got 2 on my product side. So if I pop a 4 in front, okay, that means this whole molecule now is times by 4. So that means I had 2 initially, times 4 is 8. Okay, so my hydrogen are balanced. I'm happy with that. What putting a 4 in front of this has done is it's made the number of oxygen atoms 4 also. So I have 6 over here with my carbon dioxide because I have 3 CO2s. So there's 6 oxygen there. And then I have 4 H2O. So that's times this by 4. So I have 4 here, 6 here. So I have now 10 in total. Okay, so I need to make sure this is balanced now, because I've got 2 on my reactant side, 10 on my product side. If I pop a 5 in front of this, now that's going to make that 10, and now that is balanced. Okay guys,